Today we're talking frequency. And remember how we spell frequency with a Z or a Z on the end, depending where you're from. Okay, here's the test. We took this $4 flashlight and we pulled it apart, and we of course turned it on first, and then we ran leads and put the battery down here and ran the leads all the way to the flashlight. And of course it worked because all we did was extend the leads to it. Then we thought, let's trick it a little bit, let's cut it. So we put a cut in the line here, and you can see it's about 1/8 of an inch apart in the wire, so there's no way it should conduct electricity, right? Well, except our blood is there full of carbon nanotubes, and it does conduct electricity, because watch this. If I take this lead and we connect the circuit, you can see that light down at the other end turns on. Off, on, off, on. Wow. So that's proving that that gap between those two wires is conducting electricity by our carbon nanotube blood. Wow. Okay, we're just having fun playing with our frequency, which we talked about. It's our functionalized carbon nanotubes, activated carbon nanotubes that are aligned, and they can conduct electricity. So as you can see, we cut one of the leads, and the cut is right back here. And so if I touch the blood to it, right there is about 1 inch apart, and we're getting some light there. So if I go closer, there's nice and close. So now we're going to come all the way down to the end here. And look at that. That is, we're about 5 inches apart. That's maybe, that's close to 6 inches apart. That's right at the very end. Check that out. And it's still lit. It's still lit. That's as far apart as you can be. So, man, this is fun. We're having so much fun getting this engineered down to what we need it to be, because you can imagine, think of all the applications that this could be. But yeah, conducting electricity when the line's together, when we cut it, and when we move it 6 inches apart, yeah, it's still lit up. Okay, we're having fun. Lots more to come. Here. Okay, we're going to prove here that sponges conduct electricity. Really, watch. What I'm going to do is I'm going to turn this around now. You're going to see what George's going to do, because he's actually going to take a sponge. What do you got there? Those two leads are separated by how far? 1/4 inch?
Yeah, between 1/8 and 1/4 of an inch.
Okay.
Yeah. So I'm going to push the one lead down so that I'm not pushing it towards the other lead. So it goes down. And I bring the sponge over and turn the light on. And away. And on.
So, a sponge will conduct electricity if it's got frequency in it. And our frequency is our aligned carbon nanotubes. So just to prove, we've got an actual sponge here to see if a sponge without our carbon nanotubes or our frequency in it will conduct electricity. So let's see how that does. So we can do the same thing.
Yeah, same thing. Push the one side down so I'm not contacting. And I push it into the other.
And nothing.
And nothing.
Okay, so just get the other one back again, just to show that there's no tomfoolery here. You can see all the extra frequency blood on the edge there. So he's pushing down, he's not making the connection. And then as he leans it forward, as soon as it touches, it lights the light. This is the start. We are on to something we think that's pretty big, a lot of implications.
Yeah,
so
absolutely.
Part of our engineering department here. Anyway, we just wanted to share that with you.